15 over 3 times x to the 4th times y to the 7th over x to the 3rd y to the 9th Let's just do that one first. Let's do that one first, and then we'll make it a little tougher. Okay? So when we do this one, we want to divide first. Take care of your numbers first, then your letters, and then your and then move them if you have to. And we'll see what we mean by that. So first, 3 goes into 15 how many times?
5.
5. And then when we do division, we subtract like bases. So we subtract powers with the same base. So we take x to the 4th minus x to the 3rd. So we have y to the 7th minus y to the 9th. So what we're doing is we're subtracting the exponents. When we divide, we subtract exponents. Okay? So what I have here is 5 to the x and times y to the negative 2. Okay? But I can't keep it negative. So now I have to take my negative sign and make it positive by bringing it down below. So I have 5 to the x over y squared. Remembering my rule, we have those certain rules. Up here, the rule is if I have x to the a divided by x to the b, it equals x to the a minus b. And down here I have, if I have x to the negative a, it equals 1 over x to the a. Okay? And remembering that this is really x over 1, and that what I'm doing here is I'm just bringing it down below. And in the same aspect, if I have 1 over x to the negative a, it equals x to the a. Remembering that what I did is I just put it up above. So the negative exponent either takes, you can make it positive, you can make a negative exponent positive by moving it from the denominator to the numerator, or from the numerator to the denominator. Okay? Then I'm going to show on this one. I don't know if that light's helping or hurting, but I'm going to keep trying it. Now we're going to show you another rule of thumb that's a little bit more complex. So, let's do this one. 27 x to the 4th y squared over 3 x to the 7th y raised to the 2nd power. Okay? And so with this one, what we're doing is, I want to do what's inside the parentheses first. So again, just like the last one, we're going to divide the numbers out. 3 goes into 27 9 times. and then x to the 4 minus 7, and y squared minus 1, all raised to the second power. And then I'm just going to make those numbers out. So I've got 9x to the third y all squared. So now everybody on the block gets the paper. Okay? And so I have 9 to the 1 times 3, x to the 3 times 3, and y to the 1 times, oh, I'm sorry, that's not a 3, that's a 2. 1 times 2, 9 to the 1 times 2, x to the 3 times 2, and y to the 1 times 2. Okay? So then what I end up with is 9 squared, x to the 6th, y to the 2nd. Okay? And I don't know. I want to check though to make sure that that's not hindering.
Why wouldn't it be 9x to the negative 3?
That's what I was wondering.
Ah, it is actually. Thank you. So, yes, the 9x, the x is 4 minus 7, so it's actually x to the negative 3. X to the negative 3, which negative 3 times 2 is negative 6. Good job. Way to catch me. Okay, so now what we have there is we need to manipulate the equation. So now we have 9 squared x to the negative 6 y squared. And I need to, I'm just taking this and I'm bringing it up so I can look at it. So now I need to manipulate it so that it's all the way it's supposed to be. And right now that means this number needs to be dealt with and this number needs to be dealt with. And how we deal with those is I have 9 squared, which is 81. And I have x to the negative 6. So I'm going to take that negative 6 and make it a positive 6 by putting it down below. And then this is still positive, so it stays up above. And that's how these equations get manipulated.